Hello to everyone, welcome to Pooi, the object-oriented interpreter implementing the prototype-based model. We are going to follow the workshop, and this lesson is about separating state and behavior. We are going to create the bank account object in the same way we had in the last lesson. We are going to open the inspector for the account. I'm going to create a balance and two methods. Method 1 will be deposit, which will increment the balance, and the second one will be withdraw, which will decrease the balance. That's it. Alright, so if we want to create a new instance of the bank account, we just have to copy this object. For example, we can call it account 1. And that's it. We have an account that in which we can make a deposit, for example, 500, and in which we can withdraw 200, for example, and everything is okay. But the problem here is that each time we create a new instance, by copying the account prototype, we are copying not only the state, the balance attribute, we are also copying these two methods, which are the behavior in the account prototype. This would be appropriate if these two methods were expected to change in its instance, but this is not the case. Actually, these methods are stable. They do not change from one instance to another. And from that point of view, it is a waste of time and a waste of memory to copy these two methods, provided they are not going to change. So we are going to morph this situation into a new one, in which we are going to have the behavior of the account in an object which is going to be shared by all instances of account. So this is going to become the trades account. Trades account. This is going. The name of trades comes from self, and it is related to the behavior. So we are going to delete the balance, because in this object we are only going to have these two methods. Maybe the question here is which balance is going to be referred here, provided that there's no attribute balance to modify. So let's see what happens. Okay, trades account has the deposit and withdraw methods, and now we are going to create the account prototype. This is going to be an empty object. Here it is, which is going to have balance, and also is going to derive from trades account. So here we have a new situation in which a new scheme in which A new instance is created by copying the account object, for example, account2, and we are only copying the balance attribute, and of course the parent attribute, which is trades account. Let's see what happens. Let's see, we open the inspector for account 2 and we make a deposit, for example 500. Alright, the balance is increased in 500, correct? And if we withdraw 200, okay, the balance is modified accordingly. So, how can this work? How is it that this scheme works? The key here is that we have to make a distinction between the object in which the method exists and the object which is executing the method. When we execute deposit here in account 2, this method is executed. Okay, but the key characteristic here is that self in deposit does not make a reference to trades account. Self is a reference to account 2. Remember that I said when account 2 receives the deposit message. Okay, in that situation, trades account is the object in which deposit exists, but self is pointed to account 2. That's why balance is the attribute modified here. If balance were going to be modified here in trades account, then the deposit would fail because there's no balance attribute here. There's another key feature here, which is inheritance by delegation. Here in this scheme we have the parent attribute pointing to the object which is the parent object for each one. So here in account 2 or in the prototype account, the parent attribute points to the trades account object. This means that when account 2 receives a message, for example, account 2 receives the deposit message, then account 2 tries to satisfy that message. However, account 2 is unable to do so because it doesn't have a deposit method. So it delegates, that's the reason for the name of this kind of inheritance, it delegates the satisfaction of that message on its parent. So the satisfaction of deposit is delegated to trades account. Remember, with self pointing to account 2, which is the object that received the message originally. And that's why this scheme works. And when we do a copy of an object, we are actually sending the copy message to the object. For example, here we send the copy message to the account object, but account is unable to satisfy that message. So it delegates the satisfaction of copy in trades account, but trades account is also unable to satisfy this message. So the message is delegated in object. An object does have a copy method. For example, if we type object list, we can have a listing of all methods in object, and here we found that the copy method exists in object and is executed in object with self pointing to account. And that's why the account is copied and not object. In this scheme, we also have another benefit, is that we have common behavior and different state. This is the same that happens in the class-based object-oriented paradigm, and that's why the prototype-based model is said to represent, or being able to represent, the class-based model. So the same, so we have here a test account that holds the behavior, and any change, this means that any change in the deposit or withdraw methods will affect all instances. The situation we had before is that we were unable to make a change in the deposit and withdraw method and affect all instances. We would have to go its instance one by one and modify deposit and withdraw for that effect to be achieved. Instead, we have the advantage that we could make changes to deposit and withdraw per instance, in a per instance policy. But we have to take into account that we also have a difference now, because we can modify both methods for all instances, and we also can have a per instance policy as in the previous scheme, just by adding the desired methods to the affected instance. Since we are using, or better speaking, since this model uses inheritance by delegation, this method is going to be found before this one. And that's the key that allows us to have a per instance policy at the same time as having the advantage of being able to modify methods for all instances. Okay, that's all. Hope you like it, and thanks for watching. See you later.